Alright, so let's try to use the bidirectional layer. We're gonna use it on this file. So this is the one with dropout. So let us make a copy of this file. And we can use the majority of the code. So let's open it. And as usual, I'm gonna mount the drive and then change the title of the file. So let me start mounting the drive, and then here we will add bidirectional, and then I can get away of the copy off. So let me get my code here, allow copy, copy. Here we go, and then I paste, and then the drive should be mounting. Now let me go back to the model. Here is my model. Basically what I'm gonna do, I'm gonna add layers dot bidirectional. I'm gonna open the brackets. I'm gonna keep the dropout, yeah, but I'm gonna put a bracket here so that it all fits, and the rest I'm basically not gonna touch. So let me do a run all here and see where we end up. Here we go. So it's kicking in, and it's starting with epoch number 1. This will take a while. Alright, here are the results of the 40 epochs. And let's draw the results here. What do we see? Well, actually it goes slightly worse compared to our non-bidirectional case. You can see that the validation loss is actually a few points up, and you can also see that from epoch 20 there is some tendency to go and overfit, although that the validation loss between 20 and 40 is pretty constant. So performance is a bit worse, and that should not be a surprise, because when you do the backward RNN, you're gonna lose a lot of the recent information, yeah, because you start with the most recent information, and you will lose that the further you go to the left of the network. So that's why, and since the concatenated hidden layer contains roughly half of the weight of this backward RNN, it's logical that it's gonna be a bit worse. All right.